Okay, next I'd like to introduce the logical operators. You can see to the left here, you have an operator and a keyword. So we mainly use operator syntax in C++. You can see you have the exclamation for not, and that is negation, and it's a unary operator. In other words, it acts on one operand. Then you also have the and that is the logical and, which is binary, so it acts on two operands, and that is represented by that double ampersand. Then you also have this double vertical bar or double pipe symbol, and that is the logical OR, and that is also a binary type of logical operator. So the not logical operator, you'll see we have some of these tables. These are called truth tables. So I have true, false values in here. Sometimes you'll see T and F simply representing true and false, but I wrote it out here to make it easier to read. And A here is some relational expression that evaluates to a boolean. Okay, so either true or false, or it's simply a boolean variable. So A, you can see in that first column, you can see when it's true, and when you have it prefixed right there with the logical not, then that negates that, or basically reverses or switches that, and you can see then it becomes false. If it's false, then it becomes true. Next we have the logical AND operator. A and B here are relational expressions of booleans again. So if A is true and B is true, then we get true. Okay, what it returns from that will be true. Again, this is binary, so we have two operands. So if you have A is true but B is false, or A is false and B is true, or both are false, then you'll get false. So if you have relational expressions or some boolean on each side of a logical operator, both of those have to evaluate and return true for this logical AND to then also return true. Okay, and the logical OR operator, basically what we have here is if either one of those or both are true, then we get true. Otherwise we get false. So basically we get false if both of those are false. So we have at the top here, we have A is true and B is true, so both are true. That will then also return true. If A is true but B is false, again we'll get true. If A is false but B is true, then we'll also get true. Again, at least one of those two has to be true for us to get a true back from this, okay? So if both are false, as you can see, we get false. I would like to mention that there are a few other cases. So exclusive OR, for example, you have inclusive OR and exclusive OR. Inclusive OR here is true if A is true, or B is true, or both are true. So that is inclusive, meaning that even when both are true, it will still return true. Then you have exclusive OR. Now this is true if A is true or B is true, but not both. So it excludes the case where both are true. You can see for this we need to kind of write this expression here, because sometimes we don't get an operator, so we have some of the other operators, and we have to go and combine those to form some of the other cases that we might need. Okay, so here we have that expression, and we are taking a look again at exclusive OR. So we have example 2 to the right. You can see that true and true, we have OR there, so that will give us true. Then we have AND, in the parentheses to the right we have AND, so both of those are true, so that will give us true again. So we have true on the left, and then we have and then we have not true, so that not true will become false. So then we have true and false, which will give us false, because we need both to be true in order for us to get a true back from that. Okay, so in that case you'll get a false, and that again is the case where both operands are true. Okay, so on the left here you can see that we have true for A, and for B we get false. That will eventually evaluate to true. Okay, so this is more or less how you can work this out. Don't worry about the exclusive OR too much, because for the most part we'll be using some of the other operators. So not, and OR. I just wanted to show you that if you need to use exclusive OR or some of the other cases, then you might go and basically write an expression that will calculate that using, again, logical operators. This is a fairly simple example. I have an int x here, which I will initialize to 5. And so if x is greater than 5 and x is less than 10, I can print this out, okay? X is an integer between 5 and 10. So basically we want an integer that is between 5 and 10. If it's not, then we want to print out again that value, whatever that is. Print that out and then we say is not an integer between 5 and 10. Go and run this. You can see 5 is not an integer between 5 and 10. 5 is not between 5 and 10. So just keep that in mind. I'd also like to note that we use the keyword here and not the operator. Now, as a beginner, it can be easier for you, especially when you have complicated expressions to go and solve. What you can do is you can take the operators and then kind of replace them with these keywords, so not and or, and then you can go and solve the expression from that point on. But in C++, we use the operator. Okay, so you can see, again, if I compile this, we get not an integer between 5 and 10. If you select something like 6 or 7, you get 7 is an integer between 5 and 10. So if it's not, then it will print this stuff out. Another thing I'd like you to note is you should not do something like this. So x is greater than 5 and x is less than 10. You should not do it this way. You'll see that we get x is an integer between 5 and 10. But if I go and do something like 50, run this again, you'll see we also get 50 is an integer between 5 and 10, which does not make sense, okay? And the reason why that is because it goes from left to right. And so this is 2. And what is 2 again, the Boolean 2? Well, that is 1. Okay, 0 is false, 1 is true. So 1 is less than 10. Okay, so that is why this will execute. So this will evaluate to 2 and then this will execute, okay? Not this section down here. You can see right here. I'll just undo this a few times and you can see if we have it written out correctly and I have 50 here and I build and run this, you'll see we get 50 is not an integer between 5 and 10. Okay, so in this example from the previous videos, we have this health integer, and if my health is less than or equal to 25, I check whether or not my health is 0. If my health is 0, I print out I'm dead. Otherwise, I print out I'm dying and I'm in need of a medipack. If my health is greater than or equal to 75, then I print out I'm ready to fight. In other words, I don't need any medipacks or anything like that. I'm not worried about my health. Okay, so what we want to do is we want to check for other cases, such as when we have a health of 36. So what I can do is I'll just go copy and paste this and okay, something like this. I'll print out I'm fine, let's move before they find us. Let's say we are writing some kind of text-based adventure game, okay, which is kind of the goal for the second module. So slowly but surely we will work our way up to that. So what do we need to put between these parentheses? Well, here we have a health smaller than or equal to 25. So we need to check for health greater than 25 and a health less than 75. Down here we have health greater than or equal to 75. So we want this to be less than, not less than or equal to or stuff like that. We want it to be less than. So a health of greater than 25 and a health of less than. It has to be both of those things. So I have the health set here at 36. So let's just build and run this. And you'll see that is what we get. I'm fine, let's move on before they find us. And you can go and change this to or. If you build and run this, you'll see this will work fine. The problem is when we set this to something like, high health, such as 82, for example. Build and run that. And now you'll see it will print out, I'm fine and I'm ready to fight. because both this will be true, okay, and this. So we need to check for a value between that. So just like we did in the previous example in this video, we had to check between 5 and 10. So here we have to check between 25 and 75. Okay, so this has to be an AND. If we run this now, we see we are ready to find. It'll only go down here and, this will be true and it will print that out. Something like 52. Okay, I'm fine. 13. Again, it's important to test as many test cases as you can. And then, of course, we have 0 as well, right? I just wanted to highlight a couple of examples here. So if you try and solve this problem by yourself, you might have thought, well, I can try and negate what we have here already. And so that is something that you could do. So for example, we have these two cases that we want to print out. Health is less than or equal to 25, or we have this one down here, greater than or equal to 75. In either one of those cases, this will execute and this will execute, right? Those blocks will execute. But we want to negate that. So how can we do that? We take that entire thing and we do the not of that, okay? So whatever this returns, we negate that with this operator. So if we get a value that is less than or equal to 25, this will go in here and be true. So in either case, this will evaluate to true, and then we get false, so it will skip this. If it's greater than or equal to 75, so let's do a 75, this will execute, it will evaluate this. Now this section will be false, okay, but this will be true. This is an OR, so if either one of those are true, then this will be true. Okay, so this whole thing here will return true. We negate that, or basically take the opposite of that, which will be false. So we will skip this block of code. Okay, and then this will still be true and this will still be executed. Now if we have something like 35, so I'll just go up here and change that actually to something like 35, and we go down here, you can see this will be false because health is not in this case less than or equal to 25. It is also not greater than or equal to 75 because again it's 35, right? So this will be false, and we take the opposite of that, which is true, so this will execute. Control F5 to run that. You'll see that's what we get. I'm fine, let's move on before they find us. The rest of our stuff will still work. Something like 13. I'm dying, I need a Medipack. Can do 25 too. If you want to check all of those cases, you'll see this will work. I'm ready to fight, and so on. Okay. So just go ahead and test, the various variables to make sure that your logic works. So this one is a bit more complicated to think about, but as you can see, you can do it this way as well. And it's a good idea to spend some time here and to make sure you understand why we changed this from an AND to an OR. Again, we want to check for this case, or both. So again, this is the inclusive OR. So in that case, this will be true, and we take the opposite of that. So if this up here is true, then of course we don't want to execute this block. Or if we go down and this is true, again we don't want to execute this stuff. So the inclusive OR, and we take the opposite of that. Okay, hope that makes sense.